Alright, so we are going to go over separation techniques. Now, when you're talking about separation techniques, you are just talking of methods that you are able to use to separate uh, either mixtures or compounds. So any method that you are going to use to separate a mixture or a compound. Alright. Now, to be able to understand these methods of separation, we need to understand, well, I'm talking of a mixture and a compound really. What is a mixture? Okay, what is a mixture and what is a compound? If we can know them, then how do you differentiate a mixture and a compound? Alright, so to talk about this, a mixture first, if you're talking of a mixture, think of you get this, let's say bottle, it has got sand. Okay, you get to put there, let's say, salt. So what you have done is what you've mixed. So that is a mixture. Okay. Now, where you're talking about a compound is formed by a chemical combination, right? So, please, we need to know this difference. I'm talking of a mixture and a compound. We want to understand their difference. So, as saying, a compound is formed by chemical combination of two or more elements. Okay, chemical combination of two or more elements. Now, when we are talking about a mixture is basically a substance formed by physically mixing two or more substances together. Okay, so this one is not chemical but physical combination of substances. So two or more substances. So what are we able to say that makes these two difference are different? A mixture is a physical combination. For example, myself, I get water, all right, and then I get salt. What I'm going to form is a mixture. Now, when I'm talking about a compound, this is a chemical combination. So you have got a chemical reaction happening. You have got hydrogen gas reacting with oxygen gas, and then you form two water molecules. Okay, so this is a chemical combination, and this which you are going to form is a compound because it is a result of a chemical combination. But here, if you will mix water and salt, I mean water and salt, that solution you are going to get, the solution is going to be called a mixture because it is a physical combination. All right, so this is what we need to get to understand when we are talking about a mixture and a compound. Okay, are we together? So are we moving on the same rate? All right, now since I've talked about a mixture and a compound, we know the difference between a mixture and a compound. All right, so we need to know when we have got this compound, okay, or even a mixture, we have got what we call purity. Okay, if you are talking about purity, you mean is something pure. What does purity mean? It means something is pure. Now, if something is pure, okay, what do you look at? So that is why we understand what we call criteria of purity. Criteria of purity. When you are talking about criteria of purity, all you are talking about is the things that you use when you want to know that this substance is pure. Now, a pure substance is a substance that is only made up of one substance or one pure element, right? So a pure substance is made up of only a single compound or a single element. Okay, so in other words, you shouldn't have anything else. For example, if I'm talking of carbon, for carbon to be pure, it should only be carbon. So if it has got, let me just talk of water. If I'm saying water is pure, it means it should be only water, water alone. I shouldn't have any particles of sand. I shouldn't have any particles of anything else apart from what? Apart from water. Then this water which we have is pure. Now, what do you get to look at when you are referring to a substance being pure? All right. So, what is the criteria of purity? The first thing that you are going to look at to understand if a substance is pure is you are going to look at the melting point. So, apart from you looking at the melting point, another thing that you use as a criteria or a thing that you use to identify if something is pure is you are going to use the boiling point. So apart from the boiling point, for a pure substance, you're also going to use density. So there are many things that you're able to use when you are talking about pure substances. Apart from this, you can also use a chromatograph to identify if a substance is pure. And for a chromatograph, we are going to understand this one. Okay, we are going to understand this one because it is also a method of separation. Now, how do these help us to identify that a substance is pure or not? When we are talking about the melting point, okay, the melting point is just the point where a substance is going to change from solid to liquid. So it is a point. For example, if you have got water, okay, let's say this is showing the temperature this side. The point at which water is going to change from solid to a liquid is what we call as the melting point. And in this case for water, that happens at 0 degrees. Okay, so if you have got something like this, on top we are going to have liquid water, and then below we are going to have solid water. We can see at 0 degrees what is happening. The temperature is not changing, the temperature is constant. So that is what happens during melting. The temperature of a substance remains constant. It means it is now melting. So at this point, what is happening is that you have got a conversion of solid to liquid. So you are converting a solid to a liquid. So basically what is happening is something is melting. And when something is melting, you have got a combination of a solid at the same time and a liquid. Okay, it is together. So at 0 degrees, that is the melting point for pure water. Now for each pure substance has got its own melting point. For example, pure water has got its own melting point. All right, and if you talk of any other substance, if you get alcohol, it should have its own melting point. So no two substances are able to share a melting point. One substance is going to have one melting point. That means if I have got water, let's say I've got water that has got some salt in it. Okay? This means that this water is not pure. So instead of this water being able to melt at 0 degrees, you are going to have much stronger bonds, all right? Because you know water is H2O, right? You know salt. Let me talk of even like just let me talk of sugar. Okay, we can just talk of the same salt. So table salt is sodium chloride, the salt that we get to use. So when water interacts with sodium chloride, the bonds that they are going to form are going to be much stronger. In other words, they are going to interact all the more. So it will be very difficult for you, it will not be that easy for you to convert solid water to what? to liquid water, and so the melting point is going to increase. So instead of water melting at 0 degrees, you might find that it is melting at 5 degrees Celsius, right? So melting point gets to change. Okay, melting point gets to change when a substance is not pure. Melting point gets to change when a substance is not pure, and mostly you can see that it is going to what? It is going to increase. All right, so for each pure substance, it's going to have its own melting point. This is the same when you're talking about boiling point. Now the boiling point is a point when a liquid is going to change into a gas. And same, if I can refer to water, pure water, it is going to have its own boiling point. Okay, water boils. In other words, water is going to be converted to gas at 100 degrees Celsius. So if here you've got liquid water, here we're going to have gaseous water. Okay, at this point you can see the temperature is not changing because there's a change of state happening. You are changing from liquid to gas, so the temperature doesn't change. So what is basically happening is for water, pure water, the temperature for its boiling is 100 degrees Celsius. That is the temperature at which is going to go to a gas. And if you talk like for alcohol, the temperature at which alcohol is going to change into a gas is 78 degrees Celsius. So each substance has got its own melting point, and that is the one that you use to identify a substance. All right, so I mean boiling point in this case. Okay, so if this means that if I get water, okay, if I get this water, I mix it with anything else. For example, I mix it with some salt. What is going to happen to the boiling point? The boiling point is going to increase. Why? Because you have now stronger bonds between the water. The water is going to interact with the salt, which is the sodium chloride, and these are going to have bonds, and those bonds are going to be much stronger, such that it will be not that easy to break them. Because what happens is, for you to convert water to a gas, you need to break what we call hydrogen bonds. So one water molecule is going to be pulling another water molecule like that. So these bonds which you are able to see are supposed to be broken. So if you have got sodium chloride, the bonds are going to be much stronger. And because the bonds are much stronger, it is more difficult to break those bonds. Right? Because it is more difficult to break those bonds, you are going to require a lot of heat to break those bonds. That is why the boiling point of an impure substance is going to increase. All right, are we okay? Okay. So if you talk about density, each compound or each substance has got its own density. All right, that one we also need to know. For example, when you're talking about water, the density of water is given as 1000 kg per meter cubed. Okay, it is the same. It doesn't matter as long as we are talking about water, it will always be the same. You can also express the density of water in grams per centimeter cubed. So the density of water in grams per centimeter cubed is going to be given as 1 gram per centimeter cubed. It doesn't change. It's just the same. Now, if you talk of seawater, like the water that is found in the sea, the water in the sea is not pure water. It is water plus salt. Okay, so we're going to find that the density for this water is about, let's say, maybe 1001 kg per meter cubed. In other words, the density is much higher than the normal density. So for any impure substance, the density is going to be different. All right, so you get to identify substances also by looking at their density. So immediately you see a density of 13.6, this should be grams per centimeter cubed. You should be able to identify, okay, this substance is obviously this is mercury, right? When you look at this density 13.6, you should know that this substance I'm talking about is mercury. So basically, this is how you get to, this is what we call criteria of purity. Things that you're able to use to identify that a substance is pure. These are going to come in the exam and they're going to ask you, uh, mention some criterias of purity. So these are some things that we are going to mention. Now I've not explained chromatograph because we are going to talk about that one as a separation technique. Now, when you are talking about separation techniques, you are just talking about methods that you are able to use to separate mixtures. Okay. So, for example, if I mix salt with water, how can I separate these two? All right. So we now understand how to separate them by looking at the separation techniques, the methods that we are going to use to be able to separate them. Now, the first methods we're going to talk about is methods that you're able to use to separate a solid from a liquid. Okay, solid from liquid. So, what are some of the methods that you're able to separate if you have got a solid and a liquid? And the first one we should be able to understand is filtration. Now, basically, when we're talking about filtration, really, what is filtration? All right, so this method of separation, I'm going to draw a diagram and then we are going to use it to explain what happens. So this thing that you're able to see is called a clamp. That is where we're going to put something that is going to hold. And you need to know how to at least even draw this because they come in the exam, they're going to ask you to draw or to write a representation of how filtration is going to be performed. Okay, so basically this is the setup that I'm going to see now. Let me just draw that thing proper. All right, something like this. So you should be able to label this diagram which we have here. So if you get to look at this diagram, what you are going to do is this. So before you even have what you're able to see here, is we're going to have a filter paper. Okay, you have got this filter paper like this. What you are going to do, a filter paper is, just think of it like your shirt. If you get water, you pour on your shirt, water is going to come out, right? It is going to come out from the other side. But this is a special paper that we get to use for this experiment. So what you do is you are going to fold it on the middle like this. You are going to fold it. So what you are going to have is it will just look like this. So again, it doesn't end here. You are also going to fold it on the middle here. Okay, then you are going to have something that looks something like this. And then when you have got something like this, you are now going to turn it. Okay, you are going to have something like this. you have made it in something like that. So that is a filter paper. And then you are going to get this and put it inside here. You are going to put it inside this funnel that you're able to see. It's going to be something like that. So what is the work of the filter paper? The filter paper is here to make sure that it absorbs all the solids that is in the water. Okay, so you are going to have this setup. I've already shown you how to prepare, also know how to make this filter paper like this, because it can also come. So here what we have is, we have got first this one. You need to know the name. Okay, this is the funnel. And then we have got that thing in white. I've already explained it. That is a filter paper. And then we have got this thing which is down here, this container. This is called a conical flask. Okay, it is a conical flask just by looking the way it is looking. It's more like it is having corners like that. So we can also use a beaker, okay, but we use a conical flask mostly. And then we also have a clamp and stand. This thing which is here, we have got a stand is just basically down here where the clamp is going to be supported. So we have got a clamp and a stand. All right. So basically this is the setup. Now what is going to happen is, I'm going to get a cup. This cup contains water, let's say with sand. All right. So here is a cup which has got water which was mixed with the sand. So what is going to happen is, I'm going to be pouring the water and the sand. Okay, the water is pouring and also the sand. So what happens is that the water is going to be dropping because you're using a filter paper, right? The water is going to be dropping, the water is going to come here. And then the sand is going to remain on the filter paper, okay? Because the sand cannot pass through. So basically you use this method to separate what we call uh, an immiscible liquid. Okay, all right. Yes, yes, all right. Pardon? Okay, so as I've mentioned, sorry, I've mentioned something like miscible liquid. There's nothing like miscible liquid here. We're going to talk about miscible liquids when we get to talk about uh, the other methods, which will be down here. Okay, so from here, what we have is the water is going to pass, right? It is going to pass through the funnel on the filter paper, it goes down. And when the water reaches down here, the name we give it, so this liquid which is here is called the filtrate. Okay, because it is a liquid that is collected after filtration. You need to know this. And then the sand which remains on the filter paper here, the ones you're able to see in red, this is called the residue. Okay, residue is just the remains. So that one which remains, the sand that remains, that is called the residue. Are we okay? Okay, so basically the method of filtration is used to separate, okay, like chalk from its suspension. All right, you can separate sand from water. So filtration is a method that is used to separate solid particles from a fluid. So I've got a fluid. When you're talking about a fluid, is anything that is able to flow. Okay, anything that can flow. For example, you have got liquids and gases. These are called fluids. Okay. Now basically mostly we get to separate you from fluids. So what do you separate? You separate solids and liquids. Okay. Now this solid that you are separating, it is not a solid that dissolves. Okay. So you need to know when you are talking about filtration, you separate an insoluble solid that is mixed with a fluid. Now in this case we are using a liquid. Okay. If you use a soluble, like you mix for example salt in liquid water, you are not going to see the salt, so you cannot use filtration because the salt is not going to remain on the filter paper. All right, is that okay? All right, you also need to know some applications. Where do you get to apply this method, filtration, like at a big level, apart from just you talking about this like in a lab like this one? So filtration is also used in the manufacture of sulfuric acid by the contact process. You need to know this because they ask in the exam, give some applications of filtration. So manufacture of sulfuric acid. So the process in which sulfuric acid is manufactured, this is called the contact process. You are going to understand this when you start talking about this, okay, in the contact process. All right, that is one application. So another thing is sulfur dioxide mixed with an excess of air is purified by filtration to remove particles of dust and other impurities. Okay, so the purification of sulfur dioxide, which is mixed with excess air. Remember, we said you can use filtration to separate a solid from a fluid, and air here is a fluid. All right. Another thing is another important use of filtration is purification of water at the waterworks. So purification of water. For example, before water comes to our tanks, it is going to undergo purification so that by the time it reaches, we are not going to have sand. All the sand is going to be removed. Okay. Are we good? All right. So this is one process that we get to understand. Or another method that is used to separate a solid from a liquid, apart from filtration, is called decantation. Now, what happens during this process of decantation is all you are going to do is you are going to get, for example, you have got, let's say you have got, this is a cup, okay? You have got water in that cup. But the water is also mixed with an insoluble solid. You have got an insoluble solid there. For example, you've mixed with sand, like water plus sand. So you can use decantation. Now for decantation, what you're just going to do is it's a very simple process. All you do is you're going to get the water, you start pouring it out. So as you start pouring the water out, the sand is going to be remaining on the container, or let's say your cup down there. So all the water is going to go out. Okay, you are pouring the water is going to be coming here, and then the sand is just going to remain alone. So we're going to see the sand just at the bottom there without water because you've poured out the water. So when solid impurities in liquid settle down, that's the first thing that you do. You are going to make sure that the solid settles. And when this solid settled down, like the way you're able to see, like it is at the bottom, the solid has settled down, the liquid can now, with care, like with care, you are doing it slowly, you are pouring out the what, the water. So the water is going to be all removed, okay, and then what you're going to remain with is just the sand at the bottom, right? So this method is called decantation. So one application of decantation, so decantation is applied in the separation of wine from its sediments. So that is one application. That's for an application of decantation, separation of wine from its sediments.